Greetings and welcome back to my channel, and for today we're going to have a special lecture on how to solve a quadratic equation, but not with just any old method. We're going to do this geometrically. As a student of math, you have no doubt come across many different ways to solve quadratic equations at different points of your math education. You maybe have come across factorization, completing the square, quadratic formula, and maybe even Viate's formula, Newton-Raphson, or even to draw it graphically. But oftentimes, these methods might be unreliable, oftentimes tedious, and usually the answer might be quite ugly. For today, I'm going to show you a geometrical approach to solving quadratic equation. Hopefully, you'll find this novel approach a little more elegant, and it might even stun your math teacher. What you need is to have a piece of graph paper with you, a ruler, and a compass. Let's begin. Suppose you want to solve this equation, x squared minus 6x plus 4 equals to 0. The first step you would need to do is to compare it with x squared minus bx plus c to determine what is the value of b and what is the value of c. Take note that in this example, b equals to 6 and c equals to 4. Step number 2, you will construct the x and y axis on the graph paper. Label coordinate 0, 1 on the graph paper. Step number 3 would be to plot the points b, 0 on the x-axis, 0, c on the y-axis, and together plot b, c, as I've shown you in this example. Step number 4 will be to connect the points 0, 1 and b, c as shown in the example with the red line. Then you would bisect this line to find the midpoint as shown with this green point. Using that green point as the center, you will construct a circumcircle through the points 0, 1, 0, c, and b, c, as shown with this blue circle in step 5. Where this circumcircle intersects the x-axis would be the two roots of your quadratic equation, alpha and beta. In summary, to solve the equation x squared minus bx plus c equals to 0, we can use the fact that a circumcircle through the points b, 0, 0, c, and b, c will pass through the x-axis at the two roots alpha and beta. What we can say is that these 5 points are concyclic. They lie on the same circle. But the question is, why? Why is this so? I'm going to ask you to pause the video here, take out your piece of pen and paper, and try to prove this on your own. When you're ready, unpause the video for the proof. I hope you've given this proof a good attempt. I'm going to run through a version of the proof, and if your proof is different from mine, put your proof in the comment section below and let me have a look. So, to begin, we're going to start with a blue right-angled triangle with base beta and height c, followed by a second triangle with base alpha and height 1, shown in yellow. The first step of the proof would be to show that these two triangles are similar triangles, and we're going to use the fact that the product of roots, alpha times beta, is equal to c. Rearranging this, we'll get alpha over c equals to 1 over beta. The ratio of corresponding sides would be that the base of the yellow triangle alpha corresponds to the height of the blue triangle c. The height of the yellow triangle 1 corresponds to the base of the blue triangle beta. Hence, the two triangles are similar. This tells me that the two angles marked in red are equal. Similarly, the two angles marked in green are also equal. Next, I'm going to remove the yellow triangle, leaving us a blue quadrilateral. Part 2 will be to show that this blue quadrilateral is a cyclic quadrilateral. We can do this by first noticing that this red angle and this yellow angle lie on the same straight line, hence their sum must be 180 degrees. This tells us that this yellow angle and the opposite red angle also add up to 180 degrees, and that by the properties of opposite angles of a cyclic quad, this quadrilateral is cyclic. We can construct a circle through points 0, c, 0, 1, and the two roots alpha and beta. However, we're still not done. We still need to show that B, C lies on this circumcircle. So the strategy here is to first find the center of the circumcircle. This can be done by using perpendicular bisectors. The first line segment that we want to bisect is the line segment connecting the two roots alpha and beta. This perpendicular bisector is shown with this red dashed line. This vertical line passes through the center of the two roots. So we can say that the x-coordinate on this red line would be the average of the two roots, alpha plus beta divided by 2. And by Viate's formula, we know that the sum of the two roots is equals to b. So we can say that the x-coordinate of the center is b over 2. Now to find the y-coordinate of the center, we'll use the perpendicular bisector that passes through the center of the 2 points 0, 1 and 0, c on the y-axis. This is shown by this red horizontal line. The y-coordinate of the center will be the average of those two y values, 1 plus c divided by 2. This gives us the coordinate of the center of the circumcircle. Now, using the center of the circumcircle as the midpoint, we can find the two ends of the diameter. One end will be 0, 1, the second end would be b, c. This concludes the proof that these 5 points lie on the circumcircle. Or does it? Actually, the proof is still a little incomplete because what I've done is I've assumed that B and C are both positive. So a good exercise to the reader is to try to prove it to yourself that it would be true for the other cases where B is positive, C is negative, or when B is negative and C is positive, and lastly when B and C are both negative. To give you a quick example, for part 1, it will look something like this, the diagram where B is positive and C is negative. Would the 5 points still lie on the same circumcircle? Try to take out your pen and paper and prove it to yourself that this is true. With that, I've come to the end of this video. Thank you for your kind attention and have a great day of learning.